Who knows what MDDI means? I'll give you a hint. It's a spec in the mobile display subsystem. Don't be shy. Close. You got 3 out of 4. That's worth $15. Anybody? What was it? You got it. That's for you. Okay. So the second proven system block is V. And V, what we say at QuickLogic is V, seeing is believing. Maybe during the break that Hypertransport is sponsoring, you can go back to our booth back there and see this real time with video. But I can tell you that V is believing. This is a picture that you might take on your mobile device, be it your media player or your nice new smartphone with an 8-megapixel camera. And you look at it and it looks kind of dark. You can tell it's probably in the UK with that nice bus, but you can't see in the shadows. So what the visual enhancement engine is doing is it's actually processing these images real time in your phone and boosting the perceived contrast to make it look like that. So you can actually get that nice user experience that you would expect out of your plasma TV, for example, or your laptop sitting in front of you, but you can get that in your mobile device, which is very difficult to do with low contrast displays that are often used in mobile devices. So now I have another $20, and I actually gave you the answer the last slide. What does V mean? Don't cheat. Not video. Close. Visual. Who said that? All right. You get the next 20. Okay? So they don't walk away. Right, the visual enhancement engine. So why did we do this visual enhancement engine? Basically, if you look at some of the trends in the mobile market right now, a lot of it is around data plans. Operators really like these data plans because they're getting a lot more average revenue per user. SMS, phone calls, the market is kind of saturated right now for this type of plan. But when they get subscribers like you and I on data plans to browse the web, view YouTube videos, this is what drives these high density downloads, high capacity downloads. Other websites coming on now like Hulu where you can watch tape shows on your mobile device. Again, these are data plans. Operators love these data plans. But as a subscriber, you're probably not going to buy something at $10 a month if the user experience is bad. If you can't watch the video outside on your mobile device, you're going to turn it off. And you're just going to use email, which is really not driving the heavy downloads. So the visual enhancement engine is geared specifically at these user cases, like video, like watching pictures, like YouTube, to get people to download more data. And operators are really embracing this model. So that takes us to the next step. In order to be a mobile device and look at YouTube and browse the web, you need cellular connectivity. So the build is a little off on this one. So who will be the big winner? If you look at these devices today that are connected via the cellular network, you can start on the left with the feature phone, and you can grow up to the multimedia and smartphone. This new category of devices called mobile internet devices, or MIDs, or personal computing devices, or pocketable computing devices. And then if you look at the right side, you have these devices that you and I have, netbooks or laptops, and they're coming down in functionality into this netbook or mobile computing device segment. And it's really interesting to watch this battle go on because nobody knows exactly who's going to win in this middle segment. And there's undercurrent of what processor architecture is going to win. Intel is clearly the dominant guy on the right side, and they're trying to come down to this higher volume space. Some of the cell phone guys, baseband guys, are dominant on the left side, like Qualcomm, and they're trying to grow up in the functionality. And what's happening is, and John spoke to this, processors take 2 years to define and bring to market. So 2 years ago, do you think all the baseband guys knew about the success that the netbook segment's going to have? And likewise, did Intel have this concept of what was going to be happening down in this mid space? not to the degree that they would have liked, is the answer. Everybody knew it was going to be a big segment in terms of compound annual growth rate, also in terms of units shipped. But what actually happens in the middle, what baseband or processor architecture will be adopted, what types of interfaces you're going to need, that's where that's been at some level of uncertainty. And that level of uncertainty is exactly where having a programmable platform, like what we have for our CSSPs, makes a lot of sense, because you can quickly adjust to the OEM and ODM requirements as they're getting closer to defining a product to bring it to market. So we actually like the fact that there's uncertainty in this yellow box, because uncertainty in the market brings opportunity for us to solve those challenges. So to answer this question from our perspective, who will be the big winner? We don't care, because we have a good play with all of the different processor architectures, as I'll go over in a second. So in terms of our platform family roadmap, let's take a step back. CSSPs require a platform, proven system blocks, software drivers, architecture knowledge to make the CSSP. So you need the platform. And we've been delivering platforms for the last couple of years specifically purposed for building CSSPs. On the top half of this slide, these are Visual Enhancement Engine enabled CSSPs platforms. On the bottom half, it's focused more on connectivity. Connectivity would be USB 2.0 high speed, SDIO, these types of interfaces. So not at this session, but in a future session, we'll be announcing the details of our next generation smart connectivity platform called Calder. But today, what we're talking about are V2.0 enabled silicon platforms, where we've taken the V engine and we've hardened that into special silicon devices. Now, last year we talked about VX2 and VX3. These were platforms specifically developed for the imaging and display subsystem in the mobile device. VX2 was for RGB displays. VX3 was for MIPI-enabled displays. I won't pay $20 to know who knows MIPI. You can look that up. But today we're announcing VX4. And the VX4 series is a series of platforms specifically architected with the MDDI interface. And MDDI is the display interface on all Qualcomm basebands. So this is fully purposed for Qualcomm-enabled handsets, which everybody in this room knows is a dominant guy in, step back here, dominant guy now in this segment and growing up into these segments with their new Snapdragon family. Okay, so exciting stuff. We can give you more detail about VX4 offline. I'll go through a few more slides before we do that. So VX4, from our perspective, really rounds out our V-enabled platform family, because now we have full coverage of the most popular interfaces used in these mobile display paths. MDDI for Qualcomm-enabled handsets, MIPI for most of the other guys, and then RGB, or smart CPU display interfaces like EBI. All of these platforms have some element of programmable logic, because we do need the ability to customize different solutions for customers. All of these have the Visual Enhancement Engine in it, the 2.0 version that we announced last week for availability.